So Tony, are we switching back? Are we switching back to the robot?
You could move on.
Okay.
All right, good morning, guys. Let me go over the calendar here. So I'm just going to have, rather than pulling problems from the textbook, I think there's enough practice within these classwork pages. I think that will act as homework. So for every section that we do, we'll do as much of the classwork as we can in class. Whatever we don't finish, you guys will do for homework. But I'm still going to have AP practice as part of your homework. So I organized it where AP practice or classwork problems are right next to each other. So if you flip through the packets, I put all the problems together. So if I'm checking homework, it'll be easy. It'll just be consecutive pages. So we're talking about parametric, polar, and vector functions. I think what you're going to realize is that a lot of this is going to feel familiar. You already know a lot of the processes, and we just have to kind of adapt it to these forms. So you know how to find the derivative, you know how to find the integral. So there's not a whole lot of kind of new things that you haven't seen before. You've seen it before. You just have to kind of put it into the parametric form or into the vector function form. Now, having said that, I think the graphing polar equations will be something new. I think in Excel pre-calc, we didn't do a whole lot of graphing, and I'm going to spend a day to go through the graphing. Now, you will get to use your calculator, so that's good. But if you don't know how to interpret what the calculator is giving you, then it still feels foreign to you. So I am going to go through a whole day of just graphing polar equations, recognizing different graphs, and knowing how a graph is formed, so that when you have a calculator in front of you, you know what how to interpret it. So after graphing, we're going to do polar area. I think polar area is the one that's going to feel new to us, but that won't come until the end of the unit, and then we'll have 2 days of test review. We'll start unit 10, and then we'll do a unit 9 test. So I want to give you an extra day. I want to give you a day without losing a day of instruction. So unit 9 test will be that first Tuesday of February. And then after that, then unit 10 will be our last unit, which will split up into 2 subunits. And then after that, we should be done with our new topic by the beginning-ish of March, and then start our AP review. Okay. All right. So you will need your calculators, graphing calculator, ideally. If not, you can come up and borrow one of mine here. Okay. So let's go to page. Okay, so we've been looking at graphs of one equation with 2 variables, typically x and y. Now we are looking at 3 variables that will represent a curve in the plane. So in the rectangular equation, we're able to determine where the object is located at point x, at points x, y. But with the addition of a 3rd variable, often it's going to be a variable t, that stands for time. We're able to determine when the object was at that point. The 3rd variable t is oftentimes t, but it's not always. But I think for us, a lot of times going to see a t. So it just basically gives us additional information about our graph. If we see a parabola in front of us, we know where each point is, but we don't know when the point actually reach that value, okay, or when the graph actually reach that point. So it just gives us additional information in terms of, you know, when it reaches and also how the graph is formed, which direction it's forming. Okay, so parametric equation is if f and g are continuous functions of t on the interval I, some interval I, then the equations x equals f of t and y equals g of t are parametric equations, and t is the parameter. You can sketch the curve of a parametric equation by substituting in values for t. So we have these t values, these time values, and we're going to take those t values, plug it in, and then find the order pairs. And from those order pairs, we can plot them onto our graph. Okay, so let's see if we can just start filling them in here. So here, when t equals -1, we can find corresponding x and y values. Plug -1 in for t, we get -2. Plug -1 in for t here, we get what? Yeah, 1 squared minus 1 is 0. We're just going to go down the line. And then as we find the order pair, we can plot them onto our graph as well. So -2, 0 is our first order pair. So here, 1/4 minus 1, -3/4. Okay, which is graph it based off of our to the best of our ability, approximate it. So -1, -3/4. So having these t values also gives us an idea how the graph is being formed. It's starting at this point and it's moving through like this. Plug 0 in for t. Okay, plug 1/2 in for t. Oh, sorry, 0 negative. So with that parameter t, we're not only able to see the graph, we're also able to see the direction of the graph. Okay, so in your calculator, graphing calculator, we're going to put this parametric equation in and see the graph form. So go to mode and choose parametric or PAR. Select PAR for parametric, and then you go to y equals, and then you're going to see x of t and y of t, and then plug in to x. If you try putting in x, it'll just convert it to t for you. So we'll let x equal to 2t as given in the problem. Y equals t squared minus 1. And we're going to set the window based off of what they have for you there. So once you have this equation set up, then go to window and adjust it based off of what is given to us. start with 0.2 for your t-step, but after you get that graph to show, you can make it an even smaller step, which will slow the graph down and also plot more points and smooth out the curve as well. So here, I changed my t-step to 0.02, and the graph will form a little bit slower and also more detailed as well. Okay, everybody able to get that graph to show? All right, so window T min -1, T max 2, T step 0.2, X min -3.5, X max 5, X scale will stay the same, Y scale stays the same as 1, Y min -2, Y max 4.5.
So is this like just another type of coordinate like system, like rectangular?
Right. I mean, this is still rectangular. It's just that we have an additional variable, T, that is allowing us to shape the graph or give us a certain direction to the graph. But really, we're really not going to have to do much graphing. Just want to kind of show you. What's more important is that we can convert from parametric to rectangular and to be able to find the derivative of equation of a tangent line if something is given to you in parametric. Okay, let's go to example 2. So to find a rectangular equation, when you're given a parametric, we're going to eliminate the parameter t through substitution. So we're going to figure out a way to solve for t and then replace the t back in terms of the other variable. And we're hoping that we can just get the equation as something purely in terms of x and y with the t removed. So the way we do that is we find the easier t variable to solve for. Which equation is easier to solve for t?
X equals
Yeah, so I'm going to solve for t. So on this side, so t equals what?
X over 2.
X over 2. So now we're going to take this and make the substitution into the other equation. Okay, replace t with x over 2. And we get y equals what? Yeah. Or in other words, 1/4 x squared minus 1, which is the shape of this graph, right? Here, we're eliminating the parameter, which basically is just going to allow us to just see the picture of the graph. It removes the ability to see the graph formed in this way, but we're still able to see where the graph is. We just don't know when the graph is reaching a certain point.
Back to that.
It's possible, but we're not going to have to worry about that.
Oh.
No. Okay, number 2. Given the parametric equation x equals 2 cosine t and y equals 2 sine t, we're going to try to eliminate the parameter and get everything in terms of x and y eventually. Okay, so now there's something that is useful for us to recall is that we have a Pythagorean identity that can help us with this. So remember, sine squared x plus cosine squared x is equal to 1. So we can use that okay, to help us with this. Okay, so let's just solve for x here, or let's just see if we can get cosine and sine alone by themselves. All right, so cosine of t is equal to what? Yeah. And then sine of t is equal to y over 2. So we know that cosine squared plus sine squared equals 1, right? And if I have that relationship, I can make a substitution in terms of x. I can replace sine with what? Oh, sorry, yeah, replace sine with, yeah, y over 2 squared, right? Right? Replace cosine with x over 2 equals 1. So if we know this is true, then I can just get this in terms of x and y and create an equation with the variable t eliminated. So this gives me 1/4 y squared plus 1/4 x squared equals 1. Right? To make it even more familiar to us, I'm going to multiply everything through by 4. And I'm going to rearrange the x and y. So x squared plus y squared is equal to 4. Anyone recognize what this is?
Circle.
It's a circle with a center at 0, 0 and a radius of 2. Yeah.
So it would be wrong to solve for t like alone.
Right. So this one is almost like, oh, we have to kind of recognize, oh, this is Pythagorean identity. We're going to make the substitution a different way to make it easier to fit that rectangular form. Okay, so if we have something that is in parametric form, we can get the derivative in this way. So we can say if I want to find dy dx, that's basically y prime divided by x prime of t. Or in other words, if I do dy dt divided by dx dt, I'm able to get the slope or the derivative of that parametric equation. Right. And this is assuming that dx dt is not equal to 0. Otherwise, the slope will be undefined. So given that x of t equals t to the 1/2 and y of t equals 1/4 t squared minus 4, find dy dx. So we just have to find x prime and y prime and just divide them by each other. This is ready for power rule. I'm going to clean this up a bit so I can get this ready for power rule. Okay, y prime of t is equal to x prime of t is equal to The 1/2s cancel out. I can subtract the exponents, 1 minus the negative 1/2. So the derivative of this curve is simply relying on t value. T to the 3/2 will give us the slope of any point on this curve. Okay, number 5. Given x of t and y of t is in the problem, find the equation of the tangent line. So we're going to go through the same process. We're going to find the derivative. From the derivative, we can plug in t to get the slope. And then from our order pairs, we can plug in t to find x and y. Once we have x and y and the derivative and the slope, we can do point slope form. Okay, let me find order pairs first. Okay, cosine becomes negative sine. X prime, e to the 2t becomes, yeah, e to the 2t times 2. Now that we have our derivative, we can plug in pi over 2 into my derivative to get the slope. Negative sine of pi over 2 is -1. 2e to the 2 times pi over 2. That's going to be 2e to the pi. So there's my slope. There's my order pair. Point slope form to get the tangent line equation. Okay, practice problem. Let's try number 1. Any questions so far? Okay, for the given parametric equation, eliminate the parameter and write the corresponding rectangular equation. X equals e to the negative t. And then y equals e to the 2t minus 1. I think that x equals e to the negative t feels a little bit easier to work with since there's not as many terms. So let's see if we can get t by itself and then plug that back into the y equation. Anybody still need to look at number 5? what can we do to get that t to eventually come down?
Natural log.
Yeah. Right, we know natural log of e just goes away nicely. T equals negative natural log of x. Now that we have that, we can take this and put it into the t. We actually go a little further with this. Y is equal to e to the natural log of x raised to the negative 2. Because using power property here, that negative 2 can just come up. And then here, I can write this as, well, we also know e and natural log. This is now a nice clean relationship where we can make this go away. So e and natural log drops out. I'm just left with x to the negative 2. And x to the negative 2 is the same thing as 1 over x squared.
Previous answer would be acceptable.
Yeah. Okay, number 2, we're just doing y prime of t divided by x prime of t. Okay, for number 3, we'll find dy dx. Now, when you find dy dx, it'll be in terms of t. You just have to find a way, how can I get that t to be replaced in terms of x? Number 4, think of this as related rates. All right, we want to introduce t into the derivative so we can get these values to show up. So every time we find the derivative of x or y, we'll attach a d over dt for that x or y. But we also have to involve what with that x times y here. To find the derivative, we got to go through product rule. Yeah. Okay, number 5, find the equation of tangent line. Plug pi in to get your x and y value. Find dy dx. Plug pi in for t to get your slope, and then point slope form. Okay, continue with number 5. Any questions with phi? Yeah, to find x prime and y prime, we do have to go through product rule for both. F prime g plus f g prime to get to y prime. And then f prime g plus f g prime to get to x prime. Once you have your derivative spelled out, then replace all the t's with pi, and we should be able to get our slope all the way down to pi. It's also good for us, right? As we're learning a new topic, quote unquote, new topic, we're also revisiting all the AB topics that we did all the way back in September, October. So it's good to review all those items as well. Okay, we'll keep working for 5 more minutes. So keep going. Number 6, you have your y prime, x prime given to you. We just have to set that equal to the slope and find solve for t. Okay, thank you. Wait.
On the AP exam or like on your test, do I have to round it or?
No, you'll leave like this. I mean, you'll get to use your calculator, so either way is fine.
Oh, so.
Okay, Oh, I took that slope of 1.5 to make it easier to do it by hand. I made it 3/2, and I just cross multiplied. And I just solved for t. Yeah, to get from here to here, I raised both sides to a power of 2/5 to get rid of that 5/2. That carries over to the right side.
To get dx over dt, I do x prime of t over y prime of t.
For which problem?
Number 7.
No, if we, oh, sorry, let's see your question again. Well, to find x prime, y prime, we can just insert them into the radical and try to reduce it.
Yeah, but how'd you get? Wait, so x prime of t is dx over dt.
Yeah, x prime t is dx dt, y prime t is dy dt. Yeah, they're one and the same, just different notations.
For 7, you just subbed in the trig identity.
That's right, yeah, so once I got all the way down, I realized, oh, I can just factor 9 out. And I know that sine squared theta plus cosine squared theta is 1, so I can just get rid of that, yeah.
What's inside doesn't matter.
I guess that doesn't matter, yeah, I can treat that whole thing as theta.
Okay.
The only thing is they do have to match, and they match, so that's all we need. 3t and 3t. Okay, so your homework assignment is to finish the rest of the classwork as well as the AP problems. They're all consecutive pages in your packet. And I will send out a reminder this afternoon and send out a link so that you know where the new unit pages for Unit 9, as well as where you can find the keys to the worksheets, homework problems, and AP practice. Okay. Yeah, all the way up to 16, as well as 9.A 1 through 4. AP practice 1 through 4. Yeah. Okay, finish your phones. I don't think go down here.